All right, guys, now let's have a look at question 9. It was a cubic function that was given. Let's have a look at this question. A, which is 1:9, and B, which is 5/2:8, are the turning points of a graph. Right? I think you must go and watch a video on this channel that we have that explains all the different kind of questions that they might ask you when it comes to cubic functions. What do you do if you're given intercept? What do you do if you're given turning points only, and also one intercept? All right, and then they say that here we have got C, which is 0:7, which is the y-intercept of the graph, and they didn't give us a function, they just gave us the graph as it is. So let's come here, let's have a look at 9.1. It says, for which values of x is f decreasing? All right, you will remember in analytical geometry, if you've got a function going up like that, it has got what? A positive gradient. Then if it's going down like that, it has got a negative gradient. So therefore, this is the one where it is decreasing here, because what? It's got a negative gradient. All right, great stuff. So now let's have a look at on this function. If you have a look at this one here, up here, it's increasing until it gets to this point here, where we are referring to it as a turning point here. When it gets to this point, which is our turning point here on this point, now it starts decreasing up until this point, and then it goes back to increasing again. It goes back to having a positive gradient. So therefore, in between here, what is happening? In between here, between these 2 points, where x is equals to 1 and where x is equals to 5/2, our function is what? Is decreasing. So for all the values that are greater than, for x greater than 1, okay, and then for x less than 5/2. Okay, so you can also write it in terms of this x greater than 1 or x less than 5/2. You can also do that as well. Right, 9.2 says, write down the x-intercept for f of x, the derivative of. Okay, now what do they want? They want us to write the x-intercept values, okay, which is the derivative of that. Okay, so now in this case, what do they want? They want us to write the x-intercept, which is the derivative of those. Okay, they're saying the derivative of f. So in this case, guys, they've given us these two values here. Write down the x-intercept. They've given us these two values here, which is, so if you were to take the derivative of this function, to make a parabola, a derivative of this, remember this is f of x is equals to ax cubed plus bx squared plus cx plus c. Okay, so if you take this, a derivative of this is going to give us what? A derivative of that is going to give us, I'm taking a derivative, guys, I'm assuming that at this stage of the exam, or at this stage of the term, you should be able to do this. So this gives us a parabola. So what can we do? What can this be for this to be the intercept values? So it means our parabola, it means our function will have to be like this. This will be our function, guys, with these two values here, which is the x-intercept. So therefore our x-intercept will therefore be x is equals to 1 and x is equals to 5/2. All right, you obtain this when the derivative is equal to 0, guys. All right, so which is our new function. Okay, this also on the cubic, you obtain them when the cubic function is equal to 0. All right, I mean the derivative is equal to 0 rather. Okay, so I hope you guys fully understand. Now let's move on to 9.3. Right, 9.3, it says here, for which values of x will f be concave up? Right, so for which values of x will f be concave up? Okay guys, so now let's have a look at this one. You have got starting from here, but by just looking at it, this is concave down, guys. This is down up until a certain point here. Now up until this point here, this graph starts to concave up like that. And guys, you will remember this point here is known as the point of inflection. This is what? Point of inflection. But in this case, we get this point when the second derivative is equal to 0. But in this case, we don't have the equation, so we won't be able to do that. However, it is worth noting that this point here, this point that we are referring to here, this point of inflection, it's halfway between this x value and this x value here. So this point of inflection, it's a halfway this point here. So what do you do? Because you are looking for this point here to say, starting from here, going that side, our graph is concave up. Okay, so this is what you would do here in this case 9.3. This is what you do. You will say that point, which is the point of inflection, is going to be halfway between these 2 points. So you're going to just add them together and take a half, which is like a midpoint thereof. Okay, so what you're gonna have here, if we add this together, we're gonna have 7/4. So now our answer will therefore be anything that is above this point. This is 7.4, 7/4 rather. So anything above that is concave up. Okay, so anything above 7/4 is concave up. Okay, 9.4 says determine the values of k for which y is f of x plus k will have 3 positive x-intercept. So basically in this case, guys, what are they saying? They are saying that if you were to move your graph, this is what they're asking you, move your graph by a certain constant, which is k. So move your graph in such a manner that you will have 3 x-intercept. It means your graph has to come and touch the x-intercept 3 times. So if let's say for an example, if we were to move it here, it's still not touching the x-intercept. And then if I were to move it here in the origin, let's have a look. It's touching the x-intercept here. It's also touching the x-intercept here. It's also touching the x-intercept there. Okay, so even if we try to move it a little bit lower, it's gonna touch there and then also touch again here and therefore touch again there. So you are looking for 3 positive. Okay, 0 can be positive, so they said positive, so we're looking for these 3 points here. So now what would you do in this case, guys, to make sure that you get this value here? Okay, so if you are here, you would move it by a certain value. We're going to say y is equals to f of fk. We're moving it down, so this downwards movement, it's affecting what? It's only affecting the y values. So it's gonna move down, and eventually when it gets somewhere here, it's going to start affecting the x values. Okay, so if we move it down up until this point here, you can see that we would have moved it this turning point, the point of A. If we were to put the point of A here, we can't allow it to be 0. We can't allow A to have a 0 value here on the y-axis, because now it's going to touch twice. Okay, can you see that? It's going to touch twice. If we were to move this thing down again, it's going to touch twice. Oh, all right, I'm removing my curve now, or maybe let me just put it in a different color for the sake of understanding. Here we go. So if this one here is the one that is correct, it's touching 3 times, and then our is positive. So now, how do we do this now? To restrict this value here, we know that x is going to be 1. Okay, but we can't allow this. So it means we can drop it by 8, but it can never be -1, because if you say -1 here, is going to be 0. All right, so we know that is going to be 1. It's going to be 1:1. Okay, so which means that we have dropped it by 8. Okay, so and then what else do we need here? We also did need this point here has to be so low. This one, it has to be low, but it cannot be that this point here it's less than 8. I mean it's more than 9, so we're gonna drop it by 9. But here we don't have 9 because it's gonna be what? -1. But because we're dealing with a distance in this case, I'm moving from 1 2 3 4 5 6 7, then 8 is here, and then 9 is here. Can you see? Moving the graph downwards. So already in this case we can see that, okay, our k has to be a negative number, so it's going to be -8 here in this case. All right, so now we have to put the values that the values of k that will allow us to have 3 positive x-intercept. Okay, so now in this case we're gonna come here and say -k has to be greater than 8, okay, and then but less than 9, which is the distance. But however, we're looking for the k, so we're gonna divide everything by k -1, and then k -1 here, positive. You have to remember that if you do the inequality, is going to face the other way around. So inequality will face the other way around here in this case, and therefore also in this case. So this is the kind of equation that we have. Then we can just rearrange our inequality to make it look proper. So -9 greater than k but less than -8. Okay, there you go. That will be our answer. Please let me know what you think, guys. There's many ways of doing this, but I chose this one. I know it might be a little bit tedious, but I felt like it was the shortest route to do this. But if you would like to calculate it, or you've got another method, please let me know on the comment section below, and I will be glad for us to discuss it together via WhatsApp, or you can reach me out. My number is there on my bio. Please subscribe, share this video with your friends, your classmates, your cousins, and everybody that needs it. I am Gaston Mapala. See you in question 10.